Hi, my name is Chelsea Schlautman, and I'm going to go over Module 1, Chapter 1, written exam with you guys. We're just going to look at a few problems that we have learned about. First, we're going to take a look at number 1, and they're wanting us to place the digits 8, 10, 11, 12, and 13 in these circles here going across and vertically to combine and equal 31. So what I did is the guess and check method, and I used my smallest number 8 in the center circle, and then I placed my 10 and 13 across, and that came out to 31, and then I put the other two numbers that were left, which was the 11 and 12, vertically right here, as you see, and that equaled 31 as well. I could not find any other possibilities other than just switching it where the 11 and 12 were across and the 10 and 13 were vertical. That's the only other possibility that I found to come out with 31. Next, we're going to look at question 1, part B, and what they're wanting us to do is look at the diagram shown to the right here, and notice that the 8 and the 2 in these top circles equal 10, which is in the center, and then the 2 and the 5 on the left equals 7, which is in the center, and 5 and 3 equals 8, and 8 and 3 equals 11. So it gave us 4 different examples that we could go by. And so we're going to look at example 1 first, and we have 7 in the circle, and then the other 3 circles are left blank, and we have the 4 numbers in the center. So what I did is I started out with the number 7 because it is given to us, and I subtracted that from 15 so that way we could come up with the other number, because normally what we would do is add the 2 numbers in the circles to come up with the center number. So we're going to do the opposite and subtract. We already have 7, we subtracted from 15, and then with this we're going to come up with the answer for the right square. So it's going to be 8 for the top right circle, because 8 and 7 is 15. So then we're going to do this all around the square until we complete it. So 20 minus 8 would be 12. And then the 17 minus 12 would be 5. So that would fill out all of our circles for us. And then we're going to look at the second example here. We got a 6 is given to us in our top right circle. So we're going to do the same steps we did in the last example. So we take the 13 and subtract 6, and that's going to give us 7. So our top row will be 7, 13, and 6. So then we're going to continue doing this with each of the circles until we complete them. So if you look here, I have 11 minus 7 is 4. So that way our left row would be 7, 11, and 4. And then we do the 19 minus 4, which is 15, would give us our bottom row, 4, 19, and 15. And then lastly, we'll do the 21 minus 6, which would come up with 15. We'll look at number 3, same exact problem. First, we're going to start out with the one that is given, which is 3, subtract that from 6. So our bottom row will be 3, 6, and 3. Second, we'll do the 12 on the left-hand side and subtract the 3 that we found and get 9. So that would be our left column. And then we're going to do our top row, which is going to be 15 minus the 9 that we got, which would give us 6. But then if you look, the 6 and the 3 does not add up to the 8. So that possibility cannot be solved. So this one cannot be solved at all, part 3. And then part 4, we have an 8 given to us on our bottom left-hand circle. So we're going to start out with the 18 minus 8 and get 10. Second would be 9 minus 8 is 1 for our left column, and so on until we completed it. As you see here, these are all of the answers for each row. Next, we're going to look at number 2, which says to look at the figures provided and determine the parameter or the distance around each figure. Each side is equal to 1. So for figure 1, we're going to count around each side. So it'd be 1, 2, 3, 4, and so on. So if we look at that, figure 1 is going to be 19. It takes 19 to get all the way around the figure. Figure 2, we're going to look at that one as well. It would be 16. And then it asks us to determine which figure has the least perimeter and the greatest by counting the sides. And since we've already found the perimeter of each figure, we see that figure 1 has the greatest perimeter and figure 2 is the least. Although they both have 9 squares in total, the distance around each figure will be different. So that is why 1 has the greatest perimeter. Next, we will look at question 3. This one is a little more difficult, and I have it, as you can see, it's a little upside down because instead of redrawing the entire figure, I just kind of flipped my paper. And for this one, we're going to use Pascal's triangle. And as you can see, I gave you an example here of Pascal's triangle. I wrote it out for you there. So I just, like I said, turned my paper and I kind of rewrote the Pascal's triangle in my figure to come up with my answer. So I used the 1 here, 2, 1, 3, 3, 1, 1, 4, 6, 4, and so on until I got to 20. So there are going to be 20 paths from point A to point B. And then we're going to look at number 3, part B, I'm sorry. It's kind of the same concept, it's just a little bit different. We're going to look at this figure here, and we're only able to follow the arrows in the direction that it is pointing, and we need to find how many paths that we can take to get from point C to point E. So if we look at that, I have it, this is black and white, but I did have it in colored for you. So path 1 is going to go from C to A, then down to B and over to E. And then we have a second path. I have it marked here. It goes from C to B to E. So it goes C, B, straight over to E. Then my third is going to go from C to F to B to E. So we go from C to F up to B and then over to E, because that is the way the direction of the triangle or the pointer is going. And then the path 4 is going to go from C to F to E. So we're going to go here from C all the way down here to F, and then straight from F up to E in the direction of that pointer. So that is how we would find the paths for that particular question. Next, we're going to look at number 4, part A. It gives us different figures, and we're going to have to find the value of the 2 empty squares as well as the square that is labeled X. So to find the outline squares that are the darker here in the middle, the empty ones, we only know the value of the one square, which is 7 here. So what we'll do is write it as x plus 7. And since we already know the value of the other bottom 2 squares, we add it to our x plus 7. So as you see here, I put it 8 plus 7 in parentheses plus 7 plus 3, which will get us our top number here, 25. So next we're going to combine our like terms, which is the 7 and 3, and we get 10. And then we're going to add that to the 7, and then we're going to solve for x. So as all of you know, we're going to subtract the 17 from the 25, and that gives us x equals 8. So that tells us what our x value is, and from there we can figure out what the rest of it is. We would add the 7 and the 8, and then the 7 and the 3, and that would fill out our 2 empty squares. So, and that's just a continuance basically of that. It tells us that the 8, 7, and 3, we add those, which would be 15, and then the 7 and 3 is 10, and 15 and 10 equal 25. So we figured that one out there. And then we're going to look at figure 2. Figure 2 gives us a 1 on the bottom, y2, and then also 2 blank middle squares, and then 15. So it's going to be exactly like the other one, basically. Step 1, we're going to put the 1 plus y, because we have that already, and then the y plus 2. And then step 2, we'll add like terms to solve for y. And just like before, we're going to add the like terms. The 1 and the 2 would be 3, and then 2y. And so we work that the exact same way to come up with y. So now that we know y equals 6, we can plug it in to figure it out and solve. So we plug it in where the y was at here. 6. 6 plus 1 is 7, and then 6 plus 2 is 8. 7 plus 8 is 15. So that's how we check our work. We just kind of go back and add them and make sure that the pyramid adds up as it goes up. Now we're going to look at figure 3. It's a little bit more difficult. So we're going to determine the bottom center is z minus 2, because we have a z here and a 2 here. And those two together would equal up to get this number where z is located. So what we're going to do is take the bottom 2 right squares and add them to get the middle right. So z minus 2 plus 9, which would be z plus 7. So now our pyramid's going to look like this. 27 on top, z plus 7, 2, z minus 2, and 9. And then step 3, we're going to add the 2 middle squares to solve for z. So we're going to get z plus, and then parentheses, z plus 7 equals 27. So then we're also going to add the like terms there, and then we're going to subtract to get our answer for z, which is 10. So then we'll plug in 10 for z and solve. So we'll get 27 on top, 10 and 17, which equal to 27, and so on down the bottom of the pyramid. Next, we're going to look at number 5. In this one, it gives us quite a bit of information already, so we're just going to kind of use that information we have to determine who is married to who first, and then we'll go from there and try to figure the rest out. So if you look, it says Floyd is Josie's brother. Josie and Gus dated some, but then Gus married his present wife. Kitty is married to Will. Ann has 2 brothers, and Ann's husband is an only child. So we automatically know that Kitty and Will are married. So we're going to put an O there. And so then that also means nobody else can be married to Kitty or Will. So we'll put X's all down Kitty's column and all across Will's row. And then it says Floyd and Josie are siblings, therefore they cannot be married. So we'll put an X in Floyd and Josie over here. And then it says Josie and Gus are not married. So we're going to put, and the reason we know that is because it says they dated some, but then he married his present wife. So therefore we know they are not married. So for Josie and Gus right here, we're going to put an X as well. And then our next statement says that she has to be married. Josie has to be married to David. So we're going to put an O for this one here, right here, because we know she can't be married to Will. Floyd is her brother. She definitely can't be married to him. And Gus dated her for a while, but they're not married. So all 3 of those would be an X, which leaves David to be her husband. So then we're going to look here, and it says if Ann's husband is an only child, her husband cannot be Floyd because he does have a sister. So we'll look back at our chart here, and we're going to put an X there as well. And then it says this leaves Gus the only option for Ann to be married to. So we'll put an O there. And then lastly, Sarah and Ann cannot be married to Gus. So that leaves Floyd to be Sarah's husband, and we'll put an O there. So if we really just look at the table that is given to us here, we can determine most of the data from that to get all of our information. And then the rest are kind of left for us. So pretty much solves itself once you figure all that out from the table of given information. Next, we're going to look at number 6, and it says to consider the trapezoidal numbers listed, and then the nth trapezoidal number is this long number here, where n is a positive integer. So we're going to create a dot pattern to represent the 1 plus 1 plus 1, the 1 plus 2 plus 2 plus 2 plus 1, and 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. It's a mouthful, I know. So if we look here, 1 plus 1 plus 1 is going to equal to 3, so that would be our 3 dots. And then 1 plus 2 plus 2 plus 2 plus 1 is going to equal 8. So that would be, if you look at it, a little simpler way to do it is if you look, 1 right here would be our 1 right here. And then our 2 right here is going to be our 2 right here in this column. This 2 would be this 2 in this column, and so on. So it's kind of how it gets its shape. And then same for the last one. It's going to equal 15, and we'll do the same thing there to create that. And then it says here that we notice that the 1 plus 1 plus 1 equals 1 by 3, and so on. So we're going to show how the dots in a representation of a trapezoidal number can be rearranged into a rectangle with 2 more columns than rows. So if we look here at the next page, it shows, I made another example here, the 1 by 3, it's 1 by 3, and then 2 by 4, and 3 by 5. So using the information 1 by 3, 2 by 4, and 3 by 5, we know each representation will be a dot model, 1 row, 3 columns, 2 rows, 4 columns, and 3 rows, 5 columns. And then our last one, we're going to use inductive reasoning to show the general formula used to get the nth trapezoidal number. So it's going to be n, and then n plus 2 in parentheses. So if you look here, we're going to plug 1 in for n on this first one here. So it's 1 times 1 plus 2, which is going to equal 3, which is the what 1 plus 1 plus 1 equals. And then we're going to do that also for the second one. We will plug 2 in for n and then add 2 to that as well. So it's 2 plus 2 is 4 times 2, 8. So that also gives us the same answer that we got previously. And then for this last one, we're going to plug this 3 here into the n position and add 2. So it's going to be 3 plus 2 is 5, and then times it by 3. So 15 would be our answer for that one. So it gives us the same information that we got previously, just with the actual formula that we would use instead. So I hope that that helped everybody a little bit. Thank you for your time. Thank you for watching.